Hi, good morning, good afternoon, or good night, whichever one you fall in. Today we're going to be doing a chi-square test for blank. So pause the video, read the problem, and try to determine what this chi-square test is. Okay, so now that you read the problem, there's a key word in here that kind of tells you what test this is going to be. We have three choices. It's either a goodness of fit, homogeneity, or a test for independence. Okay, in general it's easy to determine the goodness of fit and independence. This middle one is the one that's a little tougher, but this is a key word right here: differences. When you read this, we want to test for differences, okay, across these proportions. Okay, these are categorical data, so these are proportions. I could say what proportion of these people drive American cars. So you'd sum up the Americans and take that number and divide it by the total number of people in this survey. Okay, so what we want to do here is start with our null. Okay, we want to start with our null, and we want to say that the distribution of car origin is the same as student and staff drivers. For student and staff drivers, the distribution of car origin is the same as it's the same for staff and student drivers. And the alternative would be the opposite. The distribution of car origin is not the same. For staff and student drivers. Okay, so this is an extension of a two-sample proportion problem. Okay, there's many ways I could ask a two-sample proportion problem. For example, I could say, does the students who drive American cars, does the percentage of students who drive the American cars different from the staff members who drive American cars? Or I could say it like this. I could say, if we were just talking about student drivers, is the percentage of student drivers who drive American cars higher than the percentage of students who drive European cars? Okay, and we'd have to compare those percentages. So you change these into percents and you do a statistical test on the differences of those proportions. But now we're looking at differences across these proportions. Okay, so even if you switch this around, you'll probably get credit. And just to write this in, this is a homogeneity, okay, test. Okay, so this is the null. So let's go over to the second page, and in here I have this setup here where I'm not gonna, let's see if I could group these and move them. I don't think I can move these things, but let's just leave it like that. Okay, so these are your drivers and this is the origin. These tops are expected. I'm sorry, the tops are the observed and the bottom's the expected. I don't have the expected yet, but just as a review, let's say we want to find the expected for American and staff. So the way we would do this is, since it's American, I would sum up the first row, which was 212, okay, times, and I would sum up the students, sum up the staff, because I have American and staff, so I sum up the staff, which is 164, and divide that by the total number of people. And let me give you the quick reason why. Well, the expected value of in these proportion problems is n times p. So you ask yourself, I want Americans and staff. So I say to myself, well, n is the number of Americans in this case. Well, the number of Americans is 212. 212. So what would be the proportion? Now I'm saying, well, if you drive an American car, what's the chance that you're a staff? Well, that would just be the probability that you're a staff. Or would you say, out of these 212 people, out of everybody, what's the probability that they're a staff? That's 164 over 359. Okay? So it's the same formula. That's how we get that formula. Okay? So if we throw that, I was using this. So. Okay, so let's go ahead and clear out of this. Now, before we find our expecteds, okay, let's do our assumptions, which happen to have that in there, conditions. Okay, so we're actually using this as a sample to say something about a whole. So SRF was given, so we took a random sample, we actually don't know if it was an SRS, but we'll assume it's an SRS. Okay, and we'll assume that let's see, that we'll just say student, staff, independent. So that means one doesn't have anything to do with the other one, and all expected greater than or equal than 5. So check, and I'll have to wait to find this. We're going to do a chi-square test. We want to go ahead and find the chi-squared, which is equal to 107 minus, I don't have the expected yet, so I have to get the calculator, but I always like writing the formula. So if you're not sure what I'm doing, I'm going to show you how to do this in your calculator. Okay, you could do this process for every single one. So this one here is going to be 195 times 212 divided by 359. But that takes too much time. So let's show you how to do it on the TI-83. And what we want to do is, let's just take a quick little look at what the test would look for. So go stat, test, let's go up to just a regular old goodness of chi-square test, not goodness of fit, chi-square test, and hit enter. Now I have these matrices, that's A and that's B. So what I need to do is I need to put the observed in matrices 1. If you look at the calculator, the matrices here is over on the left, fourth button down, the x negative 1, so it's second matrix. Now I have these matrices. Now I need to change this 3 by 4 matrix. Okay, so I want to go over to edit and hit enter. Well, it always goes rows by column. So I have 3 rows already, but I only have 2 columns. So I'm going to scan over to the 4, just arrow over to the 4, and I'll change that to a 2, and I hit enter. Now it's going to change this. Now all I do is just enter these numbers in. Okay, so I have it in now. Now I want to go back to my test. And really what I'm interested in is finding my test statistic and my p-value. Okay, chi-squared, enter, and I have A, B. You can see the expecteds in B. I haven't put any expected in B, but after I run this test, it will put all the expecteds in B. That's how we're going to go back and check it. So I'm going to hit calculate, and this gives me my chi-squared. 7 point. So we're kind of working backwards here. Okay. So now that I have that, okay, I have a p-value. So the p-value equals the probability of obtaining a chi-square that's greater than 7.8278, and put the degree of freedom down here too. The degree of freedom is important, okay, with chi-squares, because every chi-square is different for every degree of freedom, and we got about 2%. Okay, so we have about 2%. So now I have to put these expecteds in there, okay, because I like writing my formula. So all I'm going to do is I'm going to go back to my matrix. Okay, B is now a 3 by 2, so I'm going to go down to B, hit enter. Now B is going to flash up on my calculator. Now if I want to see what's inside B, all I have to do is hit enter. So there you go. I have my expected, so I could just throw these in here. So my expected is going to be 115.15, 24.44, 55. Just arrow over a little bit. I'm just going to round to the nearest whole now. 97, 21, and 46. Okay, so it's going to be 107 minus 115.1 divided by 115.15. Just plug in these numbers in. It's the observed minus the expected divided back over the expected. Okay, so now I just worked all backwards and I have everything. So we have to make a decision here. We have to make a decision, and we'll say since our p-value is less than 5%, we reject H naught. So if we reject the H naught, then that means that we found evidence that the car origin was different for students and staff. Okay, so that's it for the chi-square test. Thank you for watching. I appreciate it, and have a nice, for me it is night. So have a nice night.